We're about to start. We are going to start in a few minutes' time. We have about 30 people in the class. It's still 3 minutes early. So we are going to join in a short while. We're going to start. We're all ready to go. So while we're waiting for everyone to join, hi, Enrico. You're the only person that's got the camera on. Everyone else is so antisocial. So we are about to start, and we are going to, today we're going to focus on the solar basics. So colleagues, if it's too simple, please bear with us. We start with the foundational, side of the business. We're going to cover basic stuff like direct current and alternating current. But everything starts with energy savings. And then we, look at load analysis, as such. So please do bear with us. We have to start foundationally as we build up for the next few weeks. So we're about to start. We've got another 2 more minutes or so. All of you all, for those that requested data, would have received data. Those that requested early in advance, and those, all the learning material has been emailed to you and have been shared on the WhatsApp chat. Yeah. So colleagues, we're going to start. We got about 37 people in. I'll just wait till we get to about 45. And then we'll commence. When you do join, please may I ask that you mute. And Miranda, can you just help us maybe with muting as well? I just want to see. Martin, this must be like deja vu from 2-3 years ago, right, Martin?
Yeah, indeed.
Cool, excellent. Just letting everyone in. Well, colleagues, we're going to start in a minute's time. We're just waiting. It's 2 minutes to 1. We are recording the session.
Yeah.
So if perhaps you jump off or you lose connectivity, and if you need a copy of this recording, Miranda will load it up into YouTube and share it as well. So we're just going to wait a minute more. We have about 42, 43 people in the class. We're expecting close on to 50. So yes, just to let you know, these are all the good and the diligent ones that are in the class today. Tomorrow is a public holiday. So many people have taken today as an extra day holiday, to get a long weekend. So tomorrow is Heritage Day in South Africa, yes. So all the people that are in the class, the 44, 45 that are there now, are all the diligent people.
That means we have a lot of time for the lessons today, because all the people have a day off.
Cool, excellent. Colleagues, we're going to start. We have about 46, 47 people that are in the actual class. And we are going to actually kick off. So colleagues, just welcome. Welcome to the second session, but it's the first topic. And today we're going to be covering solar basics that you would have read. So I made the assumption that all of you all have actually read the handout. I think I made the assumption that you also had an opportunity to review the video and the slides. And so in today's class, the objectives, as I've explained to you, that we started off with basic foundations. What's AC, what's DC, and talking about load analysis and the process you follow in building a particular situation. So colleagues, we're starting up from the bottom up. And how it typically works now is every week, we will share you a topic like what we shared with you by email. And a few days before, we'll also put it into the WhatsApp chat. So you can go through some of the stuff in advance. And when you come into class, Jos will cover a summary of that topic, the important areas, and he will then open the class for questions and clarifications. So you're more than welcome to ask questions as you go. On the WhatsApp chat. So in today's class, you'll notice there's a chat. I'll keep an eye on that chat. I'll also keep an eye on the WhatsApp chat for actual questions and into it. So, colleagues, I'm about to start. I'm just going to hand over to Jos to simply take over and to commence with the summary. If you have questions, colleagues, please put it in the chat, either on Teams or put it in the chat in the WhatsApp, or maybe even raise your hand if you want to and ask a particular question. So you can ask a question while Jos is in the classroom as well. So we're kicking off. Over to you, Jos. And colleagues, please keep yourself as mute when you join in. Jos?
Thank you, Akash. Well, good afternoon, everyone. I'm happy to be here. I will try to share a screen. Let's see, is this working?
Yep.
So you see now who is your teacher today, is that correct?
Hundreds.
Yeah. So Akash already introduced me in the last session, but the people who are new, I repeat that. My name is Jos Slangen. I'm Dutch, 62 years old, married with my wife Marjolein, and we have 3 children, 3 boys, but also 3 grandchildren, and we are very proud on that. A long time ago, in 1986, I graduated from Eindhoven University of Technology and Applied Physics. Eindhoven is in the south of the Netherlands, and I probably don't need to introduce Eindhoven as the city of PSV football, and Philips company and ASML company and some other high-tech industry is there concentrated in Holland. And since I graduated from university, I by chance got connected to the very interesting world of solar energy, and I'm working in that field since 1987. First 25 years as an employee for Shell, for Siemens, and the last 12 years self-employed with my own advising company, and mainly as a business developer, strategic advisor for several Dutch companies. And since 2 years now, I'm also connected to PUM in the energy department, doing the solar trainings. And I did that before in Lebanon, in Peru, and in Ghana. And now I'm doing this in South Africa. Very happy to do that. This is the first time we do this in this way, that we have, let's say, the concept of the videos that we sent you before. And these videos are now about 2 years old or 3 years old, and we use them now several times in this kind of trainings. And I'm happy also that my colleague Martijn Schootstra is online in this session. He was involved in the former course. So maybe we take the opportunity for Martijn also to introduce himself shortly. And when I don't know an answer to a question, he can pop in probably.
Okay,
Martijn, go ahead for a moment.
Martin, you can show us your face. Yeah, fantastic.
Yeah. Well, hello everybody. Nice to be here. So my name is Martijn Schootstra. I have been involved in the solar industry for over 15 years now. So not as long as Jos. He's really the expert here. But I think I have a feeling that you will get to see some videos with my face in it, I think, and my voice. So anyway, I hope it's all clear, and I'm sure that we will able to answer any questions today and also for the next couple of lessons. Jos, over to you.
Great, thank you, Martijn. We throughout the course we talk English, but you know we are Dutch, so ik praat een beetje Afrikaans. But when I don't know a word in English, I will use the Dutch one, hoping that you understand it. But kom ons praat net Engels, hè? I have now a whiteboard which can be used for that I type something during the course, but I hope everyone has seen the video of the first lesson and also read the supporting material. And
Sorry.
basically what...
Sorry, Josue,
yeah.
the slides are being blocked. I think you've got the handout a little bit open. Is that correct, what we're viewing?
Wait, the
You need to
slides are blocked.
maximize the screen on the slide. So yeah.
Yeah, like this?
Yeah, 100%. Thank you.
Okay. So the objective of the first lesson is to understand the basics, how we generate power, what is a solar panel, how does a system work. We have systems that work with batteries, we have systems that are directly connected to the grid, and all kinds of applications we have in the field. So get you familiar to this. And also we move into the sunshine as a resource, and also how you get information on the internet, according to the database where you have this data, because I told you last week, the basic thing of solar energy is that we all know and we all are sure that the sun is rising every day. So there is always the sun available. The question is, how long is it shining, and is there a lot of clouds, or what is the weather doing? That is the big surprise that we have every day. But when you compare solar energy to other kinds of energy, like the fossil fuel, when you go back a few million years, the oil is also coming from plants which are there because of the sunlight. But that is a long time ago, and so that is a completely other source of energy. So when you talk about oil, when you talk about coal, but when you talk about solar energy, then you use the sunlight directly to generate power, to generate electricity in this case. And first of all, I want to say that in the basics, you have two different kinds of solar energy. One is the photovoltaics, which this course is focusing on. So generating from the sunlight, generating electric power. And the second one is the solar thermal, which is not the focus of this course, but we can always talk about a little bit. That then you transfer the sunlight into heat, into warm water, which is also commonly used in, especially also in Africa, I think. But we focus in this course on the photovoltaics, the converting solar energy from the sun into electricity. Let me see. Then I go to the next slide. Yeah. This is all very basic. Sunlight, a solar panel, then a battery charge controller, and a battery and DC loads. This is the most simple systems that we know. But an even simpler system, you can also imagine, is that you only have a solar panel and a small inverter connecting it to the grid. Without a battery, this is also possible. We come back to that later. We will focus a little bit on this battery systems now for the ease of simplicity. And this solar panel converts the rays of solar into electricity. This was in all the documentation. The floor is basically always open for questions. So if you have a question, please raise your hand electronically in this Teams session.
So there's one question that I'm checking. So the first one is very simple. Are we going to get the recording of the session? Yes. we'll share a copy of the recording on the chat and by email. The second one is the wire you use there. What is the size and of it? I don't know if you've got that. You can see it on the chat. It's from Ivan. Jos?
Yeah. And Enrico is, he has a question. Go ahead, Enrico. Please also put your camera on that we see you.
Hello?
Hi, we
Yeah.
can see you. Go for it.
Yes, my question is just what I want to know, for an example, if you go into say a modular home, simple home, say 3-bedroom home, a kitchen area, just simple home. If you don't have the equipment which you can plug into the DB board and try to test how many amps does they pull per day for you to calculate how many solar panels you need to install, how big inverter you need to install, because those information come from those testing equipment you are plugging into the DB board. So if you doesn't have such equipment, is there easier way how can we try and mitigate and say, okay, the homeowner is using plus minus that many amps per day, during night that many amps during night? Is there maybe a simple way?
Yeah. Thank you, Enrico, for this question. This you are touching the really the core of this course, and this is the answer to the question. I'm standing in front of a customer, and a customer is saying, "Hello, here's my house. What do I need? What can offer? What can you offer me?" And this is, let's say, the basics, and the answer to this will be, we will do this in the course of this this lecture. Maybe not today, because there is a special day that we will move into the subject of system sizing, so that you say, okay, this is my need for energy, and how many solar panels do I need for this this amount of energy and this appliances that I have here, and how can I size a system, and how can I make a good quote for that? So how can I help my customer? So we cannot start with this. We have choose to do it step by step. So, but the answer to your questions will follow during this course, and this is also the core of this course. How do I size a system, and what do I need, and where do I buy it? So I hope this satisfies you for now, but it is coming.
All right.
Cool. There's a question in the chat. Can you see it, Jos?
Then I have to. Let me see. I don't see the chat window.
Okay. Can I ask you the questions
chat,
to make it
yeah,
quicker?
there is. I know. I opened it. So okay.
Cool. Maybe you can answer Ivan and Lebohang's questions, and then we've got one more hand up as well. Go for it. We've got Latini's hands is up after
Latani,
that.
okay.
Go answer the. Would you be able to answer the chat on those questions quickly, and then we can go to Latani after that?
Yeah, this is all these questions have to do with sizing, which is and the challenges of the photovoltaic system. All these sizing issues will come in one of the days in a few weeks.
Cool.
Okay, Latani, go ahead.
You're on mute, Latani. You have to unmute yourself first.
Okay. Good afternoon, everybody. Akash and Jos as well. My question is based on the supply. Let's say, for instance, I need to supply 500 volts, and then I see there on the chart it spoke about that the solar system gives only 15 to 20%. Let's say I have a a big motor in the house. I just want to run the water. How do I get help on that one? I need to supply 500 volts.
Yeah.
Yeah, thank you.
Therefore, let's say we start at the beginning. A solar panel is not something that can give you anything. A solar panel is a device that converts the sunlight into electricity. And the first thing that you have to know is that a solar panel, by principle, generates DC current. This also in this first slide in the lower line. The current that is generated by a solar panel is DC, direct current. And a solar panel has a relatively low voltage in terms of about 40 to 50 to 60 volts and about between 5 and 10 amps DC current. When you need more and when you need alternative current that is also generated by a diesel genset and that is also supplied by the mains electricity grid from Eskom, then you need to take care that you go from this DC to AC current. And therefore you need equipment which is called inverter. This will also come in the course of this course that we go into detail. So also your question, Latani, is that this has to do with sizing of the system. I'm standing in front of, I'm standing at the customer and the customer has some specific situation. How do I go further? And this should be the outcome of this course. So let's again start from the beginning. And all these elements will follow. And we hope, of course, at the end of this course that you have a better understanding and idea of how this all works and how you can successfully prepare a proposal for your customer and successfully install a solar system. So moving forward in this text. And the second slide starts already. What if you have devices that need 230 volt AC, which is the output of the Eskom grid? And even when you are higher, then you go to 400 or 500 volt, and then you have three phase. Also, everything is possible with solar, but let's introduce it step by step. So in this scheme, what you see here is the same sunlight, the same panel. The panel is generating power when the sunshine is on it. It goes via the charge controller to a battery, and from the battery you have an inverter. And with this inverter you can generate this 230 volts. And you can also connect DC loads to the battery. This is again an autonomous system which is not connected to the electricity grid of Eskom. So you should see that this is only a local autonomous system which is off grid. So in this case, one thing more, which is the inverter. And that can generate and also supply power to AC loads. When I go to only standalone, then everything in the green area is not concerned. So you have the module, the charge controller, and the battery. And working with this kind of systems, then you will go into the questions of what kind of solar power do I need? What kind of energy do I need? How do I size the system? What kind of devices I have? What is the power for each? And but then you first make the assessment. what is the situation in the house or in the building, or what kind of energy needs is a customer having. And then you can see how many solar irradiance do I have on that specific location. Then you can make the sizing, how many panels, how big is the battery, and how do I, what kind of charge controller do I use? What kind of inverter do I use? That's a system calculation. So we come back to that further down the road. Then also to calculate the battery and the charge controller is an essential thing in system sizing. And all this depends on the local situation. And in this system calculation, as I said, you have the solar irradiance and the number of panels, and with that all you can size a system that is specifically for the needs of your client. And for this you have tools. You will find tools on the internet, specific software that can help you. I can we can also discuss in what is necessary for your calculation and your specific system. And we can also do a specific examples further on there. Okay, so this is very general. The main components, once again, this is the main thing. The main components, once again, the sun is your input, the number of solar panels, charge controller, inverter, sometimes combined, and the battery to store your energy. And the system can, depending on the choice of the components, can supply AC loads and can supply DC loads.
Okay, yes, there's a few questions in the chat. Can I just ask you, and maybe you can answer it, and we can get some answers. So we've got one hand up as well. So what factors affect the power? Sorry, thing is just moving.
Where are we?
I'm talking about Lebokang. What factors will affect the power generation of a solar system? What factors?
Well, yeah, okay, I have it here. What factors will affect the power generation of a solar system? First of all, the amount of sunshine of a specific location, because that is the input. So the input from the sun. And a specific location, you can say, okay, South Africa. When you go throughout South Africa, not all the areas have the same solar radiation. When you go in other countries of Africa, or when you go in other areas of the world, you can imagine that you have completely different climates. For instance, in the Netherlands, we have a climate which is moderate, which means that we have different seasons. A summer season with higher radiation, a winter season with very low radiation, with a lot of rain and a lot of clouds. So that is completely different throughout the year than when you compare it to South Africa, where you also have some seasons, but less or completely other than in the Netherlands. So the first is the factor is how many sunshine you have. And this number of sunshine throughout the year, which gives you numbers of sunshine average per month, you can find that on specific software on the internet, which is also for free. You have software which you have to pay for, but there is a free sites which we will see in the course of this lessons. So that I show you. So that is one thing. Then, which affects the other thing is how many panels you use, or what kind of panels, and how do you connect them. And that is all generates the output of the total system. And when you focus on the output, then how do you start a discussion with your client or with your counterpart of where you want to install a system? So you first have to discuss what is really the need of your energy. And the first thing that you try to do is to reduce the energy need, basically. So start reducing the energy need is something that is always good, because when you talk about a solar system that is generating energy out of the sun, it is something that has to also to do with an investment. The higher power you need, the bigger investment you need. So when you first try to reduce energy that you don't need to pay for it. That's a simple thing. And when you know as good as possible what you need, maybe on a daily basis, maybe on a monthly basis, or maybe on a yearly basis, then you can really size your system towards your specific need of energy.
Yeah,
so that is very important to know. Then also there are other factors, of course. How do you install your panel? Do you install it in South Africa towards the north, towards the sun? And what is your tilt angle? There are other factors. Is there a lot of shading? Are you in between a lot of trees? That can affect your energy generation also. So all these aspects will be discussed also further in this course. So this is also a good question. But the answer is not that simple. The answer is a lot of things that can affect the power generation of a solar system.
We've got quite a few questions. So I need to just pick it up a little bit. We're 30 minutes into this. So you've answered the question: the amount of sun, number of panels, what you're using it for. How is it installed into it as well? So we have a question from Kent, Johannes first, and then Kent, and then we'll take some in the chat. Johannes, you want to go first? You got your hand up. If you can maybe unmute, Johannes.
Johannes de Hoge.
Hello. Hi, Johannes. Are you there? Yes, we can hear you now. Go for it.
Okay.
Yeah, hello.
I wanted to find out those software that you found on the internet. Are they free software or is it software?
Yes, there is. Yes, thank you for the question. There is free software available. We will share all these links, and we will also try to do some exercises with it. So the free software is available. There are also packages when you are really professional where you can take a license, and then you have to pay something. That is, but both versions are available. And for simple systems, the simple free available software is more than enough to work with.
Okay, no problem. We'll go to the next one, Kent, and then Latanya, I'm going to get to you.
Okay, thank you. Mine is not a question per se, but then it's a proposal to say we take a different angle. To say, how about you present and you cover the certain topic, and we understand so that all questions are related to the topic, because we have different knowledges pertaining this issue. Some of us have minimal knowledge. So if we're going to take just random questions, it loses our concentration on the basics that maybe one needs to catch up. So I was just proposing to say, how about we just focus on a topic, and after covering the topic, then we can allow questions and stuff so that we focus.
Okay, Kent, yours is very much just like Latanya. We're going to continue with the slides, but Kent, we also share the video and the slides in advance. So we make the assumption that you would have been through it in detail. But I take your point, I take Latanya's point. So Jos, can we do a very quick summary of the slides, please? A quick summary, and then we can open the floor. The whole idea about the class interaction is to engage with you, ask questions, and to learn as well. So maybe a quick summary, Jos, and then can we start to answer some of the questions? Thank you, colleagues.
Yeah, thank you. Let's go very briefly through the slides, and then move on. So in solar cells, this is a very bad picture basically, but a solar cell is blue or black, and when you have a lot of them, you have a solar array. But good to remember is that you have solar energy you can do from a square inch to a square mile, and even more than that. And also the very big systems. There are examples in Africa, South Africa as well. So the building block, the solar cell, and how it generates power. It is a direct conversion from sunlight to electric power. 15 to 20 is mentioned here. At the moment, the commercial solar panels are 20 to 25 already. And these are some slides on how it really works, or going into more detail of every solar cell generates half a volt. And when you have a larger cell, you generate more current. And when you have more clouds, you generate a smaller current than when you have full sunlight. That should also be a very clear thing. So these characteristics of a sunlight, half a volt for one cell. And when you want to have more power, more voltage, you connect cells in series, and you connect solar panels in series. And for generating more current, you put it all in parallel. This is a very important thing to understand, and maybe I'm going into detail a little bit further, some more detail. This IV curve, where you have current here, a voltage in this way, you see this half a volt, and about in this example, 2 amps of a solar cell, and 1000 watts per square meter is the maximum sunlight radiation. And then the solar cell follows this curve. That should be, you should understand that, and you operate this curve in a certain voltage where you have the maximum power. This is all done automatically by the controller and by the inverter. So you don't need to bother about it, but you need to understand it in the background that a solar cell can have various currents and voltages, and you should always know what is happening and what you are measuring. When you take a simple voltage measuring device and you measure on a solar panel, you should always know what to expect. So then solar module is a small exercise of to understand this. This is the maximum power points with different irradiation, and a data sheet of a panel, how to read that, what are the numbers. We can go into that also in detail when you require that. Then the electric controller, how does it work? Electric controller always focuses on the maximum power point. So to extract the maximum power of a solar panel, and in this case, to charge a 12-volt battery, your maximum power point is between this 13 and 14 volts. And this electronic controller takes care of that. So in this case, when you charge with a panel a 12-volt battery, you have specific controllers for that. When you go to higher voltages or higher currents, or when you go even connected to the grid, you have other equipment to do that. And then this solar resource, just to know that you have definitions of the solar radiation. Though you find sometimes on the internet or in books, you'll find the global horizontal irradiation, which is the irradiation on a horizontal surface. And when you have a tilted surface, you can imagine that you have another number. And sometimes you want to know this number because you're going to tilt your solar panels because your roof is tilted, or you mount it in a tilted way to optimize your output. And you want to know what is the tilted irradiation. And also for that, you find calculation programs. This is all done for you. You don't need to calculate that by yourself. And this is the example for Durban of this global solar atlas.info. This is the basic, the free source on the internet where you can find your yearly radiation of a specific location. You go there on that site, you fill in your place where you are, and there is Google Maps behind it, and the output is that you get your radiation, your figures of radiation throughout the year, and so your annual average in kilowatt hours per square meter per year you can find there, and you can calculate with the number of panels that you have on your roof or on your system how many megawatt hours or kilowatt hours this generates in a year. And then you see here a graph of monthly figures, specifically for South Africa. You see here the winter or the rainy season, and here the more seasons with more sunlight. And this is the sheets for this lesson. So let's see what kind of questions we can have now. We have now in the chat and in live. Kanki, business enterprise.
So,
go ahead.
Yeah, so let's answer the chat questions first. There's quite a few in there, Jos.
Okay.
And I'll start from the top. Give me a
So the
second.
challenges we had, the difference between photovoltaic solar, concentrated thermosolar, and which solar systems panels are used in water geysers. These are different questions. You have photovoltaic, which generates electricity. You have concentrated thermosolar systems, which generates also electricity, but that is on a utility scale. Then you first generate heat, then you generate steam, and this is not for households, this is not for small buildings. You can only use that on large areas in the desert, so that is completely different than photovoltaic. And which are used in water geysers. These are the thermal systems where you have, let's say, a panel where water flow is through it, and you directly heat the water. So that is also different from photovoltaic. Then the factors affecting the system, we already got that. Then is again on thermo. The software is for free. Then what is cell module string array? Is it cursor limitation? I do not exactly understand your question, but a solar panel is, let me try to answer it as simple as possible. A solar panel is generally a sheet of glass of about 1 to 2 square meter in size, or modern large solar panels even go up to 3 square meter. And within this solar panel, there are grouped several solar cells, typically 60 to 70 solar cells, because you want to create a power that you can handle more easily. So basically, with this solar panel of a few square meter, you generate about in maximum power about 400 to 500 watt peak on modern solar panels. And when you need even more power, you're going to use more solar panels. You connect them in series, so connecting -2 plus and -2 plus to make a whole string of solar panels. So you increase the voltage, and when you put a few strings in parallel, you increase the current. And what you do generally, you increase the total power that you can generate with the system. More solar panels means more power. The connection in series or parallel, which is the best? That depends on your application, I would say. So first, you look to your application. We will go into more detail when we size the systems. I cannot say what is the best. That depends also on your inverter, on your application, and what kind of electronics you have. So that is typically on the case. How long do solar panels last? Good question. Modern solar panels are, let's say, they have a guarantee period of 25 years, and the expected lifetime is even more than that. You can do 30 to 40 years, but also depending on how you treat them. When you have a new panel and you shoot on it with a bullet, you go through it. The panel is destroyed. So when you have other kinds of demolition with stones and whatever, you can demolish a panel very quickly. But when you install it in the right way and you take care of it as an owner or as an operator, your panel will last very long. And the main reason for that is that the producers of solar panels, they have produced it in a way that it can last for this long lifetime, for 25, 30, 40 years, outside in the dust, in the full light, in the low temperature, high temperature. And you should also install it in the right way. And then, because it also has the situation that you can have high storms, high wind, or high rain or hailstorms, that can also affect the lifetime. But typically, a lifetime of 25, 30 years is normal. Then we have a question. When the solar panel is dirty, the absorption of sunlight is affected. Yeah, that is correct. Which will also affect the generated power. That is also correct. My question is, how do we clean the solar panels? Do you need a special thing of water? Maybe deionized water. A good question. This is also a part of, let's say, O&M of solar systems, operating and maintenance. Part of the maintenance, when the system is installed, it will be open to all kinds of weather conditions. And the first answer to this question is, when it rains, the solar panel cleans automatically. So, but in some areas of the country, especially also South Africa, it doesn't rain that much. So when a panel is very dirty, you can clean it. Never use very aggressive cleaning material. Rinse it with water. Deionized water is the best because you don't leave any calcium or whatever on the panel. But when you don't have that, and we can imagine that you don't have that, then it's cleaning with some cloth which is moisture or which has some water is enough to clean the panel. But don't use aggressive things to clean it. You can affect then the frame and all kinds of material on the backside. So only water, and deionized water is even the best. But when you don't have that available, only water is enough. But only clean when it makes sense. That is also a very important lesson. When you have to make a lot of cost to go on top of a roof or to go on top of a high building, and you have to clean it, and the next day it is dirty again, then maybe it was not worthwhile to clean it. So always also think, what is the effect of cleaning?
Yes, can we stop there for a minute? We've got two people's hands up, so we'll come back to
Yeah.
the questions in the chat. So I see Kent, you got your hand up, and Kanki. So let's start with you, Kent. Kent, maybe unmute yourself.
Thank you. I've got a few questions. Part of my question was the one of the debt can affect the panels. So, but
Okay.
then maybe to just have a further question on that, to add on that question is to say how do we determine that the efficiency of the panel is affected by the debt? How do we get to there to know now it's time to clean that panel? Then my other question will say on the 2018 on the 15 to 20 energy that is can get absorbed from the panels. How do we convert or how do we determine the 15 to 20% into voltages? How do one gauge to say when it's the 15% it can be converted to certain what you call voltage? How do we do that?
Yeah.
Another question that I have is to say, how do we determine the battery size that the panels, like let's say I've got for number of these panels and this then the voltage or of the battery that I need, the battery size. How do we interlink the two? Then number.
Okay.
Yeah.
Okay, we're going to
my
stop
last
here. We're going to
question.
come here. Can we just complete these
Okay.
3 questions and then we'll continue, right? So the first
Yeah.
one is, when do you know? That's, like yours, like, when do you know when it's dirty enough, to be cleaning? And then the second one on the,
Yeah.
so maybe I'll
First
go for
question,
these 3 questions.
When do you know, is it dirty enough to clean? This is not easy, I would say. This is a matter of experience also. And when you see only a slight dirt on it, it will affect the panel, let's say only a few percent. And even a lot of sand on it, when you have after a sandstorm, you will never lose more than 10%. But when you have real dirt, which is black and sticky sand, even when you are close to animal farms, the air can be very sticky and you have a lot of black dirt on it. Then go ahead and clean it. But it is difficult when you have no measurement equipment available to measure it quite in detail. So first rule is let the rain do it. Second rule is do it when it is really dirty and only when it has makes sense. So when the costs are very high to clean it, then let the rain clean it.
Okay.
It is also a matter of what do you expect from the system and how much efficiency you want to get from it. But it is a matter of experience how much to clean it. In large systems, there is also a rule of thumb. In large systems, we say once or twice a year is enough, or when you are in special conditions when you need more. But once or twice a year, that is an advice to clean it and not more than that. And then the second question had to do with how do I measure this? This is very, very special but then you need special measuring devices that can measure power or current and voltage may be enough. But that is out of the course of this lesson, I think. There was a third question. I forgot that.
Determine the battery size. How do you determine the battery size?
How do you determine the battery size? This is also captured by the lessons of system sizing, and that depends on the energy needs. That I would say, and in this question, on this answer, I would leave it by that. Depending on the needs of the special application.
Okay. So,
but we come back to that in the lesson of system sizing.
Okay, so the system sizing is lesson number 4. And then, but it all depends on what energy you need. Okay, cool. Excellent. Can I take just one more from Kanki? And then we can go back to the chat and come back to Kent. Kanki?
Yep.
Your hands are up, Kanki. You unmute first.
Can you unmute yourself?
There we are. Fantastic. Go for it.
Okay,
ask
go
your
ahead.
question.
Good afternoon. Good afternoon, Akash. Good afternoon, Yosh. Good afternoon, everyone. Yosh, I just want to tap into your 3 decades of experience. Here, when you're answering the question, you keep saying according to your application, and I respect that. However, as an installer, when I go to a house, because do you agree with me that we can have 10 panels on my house and the neighbor has 10 panels, but we don't get the efficiency of charging your system and how long it lasts and all those things. I know it depends on your cells, your composition, and how you configure it. But with your 3 decades of experience, I would like to ask what is it that which you as a expert that you will give to us as installers, that okay, if you can have this and that, because we don't want to come back and we don't want to lose client. We want to have a clientele. When you installed, everybody need to recommend that this guy did this job and we had everything. And by so saying, you basically have that which you can say, give it or take an ordinary 3-bedroom house, just built, and what do you recommend to have in terms of your panels, in terms of your inverter, in terms of all those things? I think it will help a big deal when you're going for installation and all that. That you have an efficiency system. You don't just go and buy and you say, hey, I respect that you say according to your application, but can you just go a little bit deeper in that regard? I thank you.
Okay, cool.
That is, thank you.
Colleagues, before yours answers, I need you to keep your questions short, and let's just ask one question each. And if you've got many questions, if you can put it in the chat, go for it, yours.
Yeah. This question has to do with the real practical business, and especially in a country. He is asking for, when you have a standard 3-bedroom house, what do you recommend for a system for them? And first of all, is then my question back to Kanki is do we have a situation where there is a grid from Eskom? Yes or no? Do we have a situation where we are remote in the country, where these people only have a few lights and some telephone chargers and maybe not even a television or a fridge? So and that is what I mean, depending with application. So in what area are you active, and what kind of residential system you talk about? And you can look to what is generally proposed in an area of these in this business. So that can be a small system with a few panels and a battery, and with that you can charge a few appliances. You have some watt hours available per day. But when you are in a situation where you have an Eskom connection, where you have load shedding, for where you only have grid for a few hours a day, but depending on your situation of the house, you need much more energy. Then you have to think about I need a few panels, and I need also a battery. And maybe this a big house has already a standard genset there where you want to save diesel. So again, this question also generates questions again, and there is not a very standard solution available. But you can see that for specific groups of applications, you can use the same system size, and therefore you also see that you have available from wholesalers. You have equipment available which is already composed on this optimal system design of some kind of a one-family house or even a bigger family house. So that is still depending on the situation. So maybe and in the session of system sizing, we will also come to that. And one of the starting points is also You have maybe, or basically you have three starting points. First is how much energy is needed throughout the day or throughout the month. How much space is available physically?
Yeah.
Is that the leading factor? And how much money is available? So the budget.
Okay.
And that is, and answers to these questions will depict your basically your size of the system.
Okay, excellent. I see some of the questions are getting answers. I can see one hand up, but can we quickly go into the chat? They are much more quicker. And just can we start to answer them as quickly, a little bit quickly as possible?
Yeah.
If we start looking at it, I see somebody's already answered if my battery will burst, and that's the purpose of the charge controller. I see that's been answered. And I'm on 1443 at the moment. In the event the sun resistance can't reach the solar panel due to blocked, do they need to be cleaned constantly for better life? I think we've answered that twice a year on average, but you must judge when to clean the panel. It depends on the dust type, if it's light dust type or
I answered that already.
Okay, excellent. In my notes, it says more sunlight will generate more current, but then solar modules work best at low temperature. May I please get more clarity on this, please? I thought we need more sunlight and heat to operate. I know it. I
can answer this quickly. This is a very confusing thing in solar panels. When you have more sunlight, you generate more energy. That is the first thing. But when you have a higher temperature, then there is a second order effect that affects the panel, that it is generating a little bit less energy. But the first thing is the light. When you have light, you generate energy. And a solar panel is working better when it is a little bit colder. But that is a second order effect. So first of all is the sunlight.
Okay.
Then are solar panels prone to be damaged by lightning and hail? Are they repairable though? Lightning, when you have a lightning strike directly on the solar panel, everything breaks. You cannot design anything to withstand a direct lightning strike. But lightning in the neighborhood, is not affected to solar panels. So that's very positive that they don't break. When you have electronics, you have to protect very carefully for lightning strikes, but solar panels itself, they can withstand that. So that is one. And when you have hail, when you have big hailstorms and you really break the glass, this is not repairable. That is, but the glass of solar panels is a special glass which is hardened, which can withstand normal hailstones of 3 to 4 centimeters in diameter. So that is like this small golf balls, I would say, no problem. There was a test recently in Europe on a golf course where they tried to break panels with golf balls, but they didn't succeed. So that is just to show you that that normal hail the panels can withstand, but when the glass is really broken, the panel can generate still some energy, but that it will not take so long anymore. So it is not repairable.
Cool.
Then let's continue there. What mix different power rated solar panels? You should not do that. That is my recommendation. Not mix different power rated solar panels. Try to use the same panels in one string. Normal glass, special glass, or the panel is always made with special glass, hardened glass. When you want to add more solar panels to the ones my client already have to increase power generate, is it doable, or do I need to replace all the panels? Will the panels overpower the old panels, or will they merge and give us the desired power needed? In this case, I should have some more information on the situation, but the general advice is that you connect the panels to a separate inverter as well. Or at least a separate input of the inverter. So do not connect the same panels in the same string, but always connect them in parallel to other strings. And when you have space and you want to increase the system, that is very much doable. But always keep in mind that you have to secure your overpower ratings or your fuses or whatever you have in the system, that you don't blow out the whole situation of the customer.
Cool. We just got 3 more, 4 questions, then we go back to the live
I see
audience.
a business opportunity in cleaning them. Yeah, there is in Europe there are businesses which are only cleaning solar panels. This is a business model in itself.
Okay.
So go ahead with that. What factors affect the performance of solar panels? This I already mentioned. Rule of thumb requires 4 panels per battery. Depends on the battery. When you have a batteries of 100 ampere hours, 12 volt, connect them with 4 panels. It can do. It can do. But there are more batteries available. How can I monitor the performance of my solar panel system? When you have a modern system with an inverter, it normally connects to the internet, where you have a platform where you can monitor. How do we diagnose a non-functioning panel? That is sometimes not easy. When you have a lot of panels and you have one non-functioning, the first question is then, how did you know that it was non-functioning? But you measure per string, you disconnect strings, you measure the voltage, and you can compare voltages per string. And when you have a big difference, that is a string you want to have, and then you have to look into that string. The first of all, I would advise to look at a loose connection of, normally it is the connector in the cabling which is faulty, and not the solar panel itself, unless you see mechanically that it has been broken. What is the lifetime of a solar battery? How to check the batteries if they're all working, and how we know if one battery is damaged or not holding power? How do we maintain these batteries? Yeah, there is a full lesson on batteries. So I want to park this answer, because this is also not easy, and there is a full lesson in 2 or 3 weeks on batteries. So all these questions will be answered then.
Cool.
The size and watts per panel, this also has to do with system sizing.
Cool. So I think this was just answering the questions. And then we have one last one, and then we're going to go back into the actual what happens when I combine both monocrystalline and polycrystalline on the same system? Is that possible?
Yeah, I answered this a little bit already. When you have older panels, which are often polycrystalline, and all the modern panels are all mono, because polycrystalline are not being produced yet in modern factories. So when you want to upgrade a system at your customer, then my advice is that don't mix up panels in one string, but put new strings, maybe a new inverter or a new controller next to the old one, and connect them, let's say, behind the inverter or behind the controller to the battery system. That is my advice there.
Okay.
Due to high loss on energy, have you tried anything to lessen what?
I'm not sure what the question means. Yeah, neither do I. Maybe Toba can rewrite the question or clarify it. Can we quickly go to the people who's got their hands up at the moment?
Yeah.
Into it as well. So maybe we'll start with, please, I apologize for having your hand up so long. So maybe we'll first start with Vuyo, then Toba, and then Andrew. Vuyo first. Vuyo, you want to unmute?
Hello, everyone. How are you?
Good. We can hear you. Go for it. You can answer your question quickly, please.
Okay, I needed just that we can go to the junction box so that we can know regarding the junction box on the solar panel, so that we can know the ones that they got the diodes, the one that they don't have the diodes. If maybe you have an emergency at home, or maybe one of the module, it has a problem how to replace the on the junction box. So I needed that one on the closure, that one. Thank you.
Yeah, you probably talk about a very old solar panel where you can still open junction boxes. Modern panels have completely closed junction box where even the diode which is in it sealed or is completely put into resin. So you cannot repair that or even interchange that. So when you want to replace it, replace the solar panel. That is my advice at the moment.
Okay. Toba, your hands up. Unmute and answer your question, Toba.
Afternoon, everyone.
Hi.
It's just a follow-up question on the laws. I see on the pamphlet that you gave us, there's high loss, there's high energy loss. My question was, have you ever tried anything to lessen the loss? Because we only get 15 to 20% of the energy.
Yeah, you get this 15 to 20 is the efficiency of the solar panel. So that means the efficiency of the solar panel from light to electricity. So it the energy which is in the solar ray, in the radiation of the sun, is converted with an efficiency of 20, and in the very modern panels, even 24 or 25% of efficiency. And this is standard for these panels. When you go down the road and down to your inverter and the controller and the cabling, in all these components, you lose energy. And you use the energy in the end in your appliance. But it is as it is, and you can try to increase this efficiency, but that is a matter of producing solar panels. And that is what continuous research of the solar panel producers is happening there. But when you install a system for a specific load, then you have to calculate with this load and with the panels that you have.
Okay. So
but also this is again something for the system sizing lesson.
But you were saying that you only get efficiency up to 15 to 20%, that's standard, and maximum you get up to 22 to 24%. So other than that, you can't have higher levels, colleagues, of it as well. So Andrew, your hands up. You quickly maybe unmute and ask your question. Andrew?
Good afternoon, everybody.
Hi, Andrew.
My question is that if I've got some panel, I put it maybe some panels, and they give more power on a inverter, and then on the inverter they rated the voltage supposed to be from the panel to the inverter, and then I changed it was series. When I changed to the parallel, it's starting charging slowly. Maybe it can take 6 hours or 5 hours to charge my battery. So I have to add the panels, or what I supposed to do?
I don't know if I completely understand your question, but when you connect your panels to inverters and then you want to change something?
No, it gives me more power. Maybe it gives me 280 something voltage. So it was on that time it was series. When I changed to connect on parallel, it gives maybe 190, 195. Because on the inverter they rated 200. So when I connected in parallel, it started charging slowly. Maybe it take you 4 hours to fill up the battery. I don't know if you can.
When you connect in parallel, or when you put to your string more strings in parallel, you increase your power. That is correct.
Come again?
Yeah, I don't know if I understand your question in detail. You were talking about a specific voltage where you connect your to your inverter.
Yeah.
But always look into the data sheet. Always look into the data sheet of the inverter and to the what kind of input window you have. So all these inverter manufacturers, they have and those are also for free. They have design software where you can easily can design a system. When you say, well, I have a specific inverter, how much solar panels of which brand can I connect to this inverter, and how much do I have to connect in series, and how much strings I can do in parallel. All this is can be done online on the website of this inverter manufacturer.
Okay. So coming back to it, if you haven't answered your question, maybe we can drop me an email and we can take it off one-on-one. German, you got your hand up, and then we're going to go back into the chat. German, maybe unmute and quickly ask your question.
Hello, how are you, everyone?
Good.
Yes, I just want to know, is it the difference of the panels, or the panels are the same? The only difference is just the branding, or there is the fake ones, or all are the same? It's only the difference, the sunshine, or all are the same? I just want to know the difference between these panels, because there are the different prices from the stores. Are the same, or there is a difference there? I just want to know that.
Yeah. The straight answer to this question, what is the difference between a Toyota pickup and a Mitsubishi pickup? It's not that much. And when you have two panels of two brands, and they have a data sheet which they say 400 watt peak, and the other one is 390, yeah, that is a little bit difference, but basically those panels are almost the same. And my advice for which brand can I use is look into your business relationship that you have with your wholesaler, and see what brands he has, where he can give his guarantee and his good price and his good advice. That is my advice to you, to choose for a certain brand, because most of the brands is they look all the same and they are almost the same. The solar panels are almost commodities. The difference between different brands is not that much.
Okay, excellent. Can we quickly go into the chat and start to complete some of the last few of the questions there? We finished how...
What advancements in solar technology should homeowners be aware of? I think for homeowners at the moment, it's still very good to know that they can make use of the power of the sun. And just to refer to my last answer, when you have when you are this company and you want to advise your customer, in this case, advise to have a good brand which is well renowned, and do your job as an installer well, then you can build up a good reference base. That is my advice.
Okay, excellent. The last question that's there.
The white cube.
Regarding the solar panel rating, if it is rating 500 watt, this 500 watt, be aware, is the maximum power that a panel can generate under standard test conditions. And standard test conditions is something that only normally occurs in the laboratory or in the factory. When you have, and this is defined decades ago, in order to compare different solar panels with each other. So when you talk about 500 watt peak, that means then you have a certain amount of light at a certain temperature, at a certain spectrum of the light you put on the solar panel, and then it generates this 500 watt. But you can compare another panel. When another panel is 450, then it means that it is 10% less under the same conditions.
Yeah. Okay, fantastic.
Yeah.
So colleagues, I also see Ryan and has also answered the same questions just after you mentioned it's under optimal conditions, that it's working. Thank you, Ryan. Thank you, David, for also answering all the other questions earlier as we're going to it. I see we have one more hand up in the class. So Ryan, you're going to go for it. You can maybe unmute and then ask your question. Ryan?
Okay, greetings, everybody. I just have two very brief questions.
Yep.
So it is my understanding that current photovoltaic cells convert visible light into electricity. what I would like to know is why visible light and not something like ultraviolet rays, being that UV rays carry more energy and can penetrate through clouds easier than visible light. So why do we
Why
convert?
visible light?
Yeah, why do we convert visible light as opposed to ultraviolet light?
Okay.
Yeah.
Second question.
Good. Good.
And
Thank
then,
you
yeah,
for this
second
question,
question
which
would
goes
be,
into very deep physics. But the simple answer is visible light is always available all over the globe, but also ultraviolet light is also within the same conditions available. But making use of the material, which is silicon, which is based out of sand, this material is the feasibility there is that it only converts light within a specific spectrum, within specific colors and in this case visible light. So the solar cell and the solar panel is optimized for these conditions to have as much output for the lowest cost.
okay, so if I understand correctly, then if we had to convert UV rays, it would require a different type of technology within the panels themselves.
Yeah, correct.
Okay.
And
then just
the availability of UV light is much less than visible light. Visible light is always there during the day. Yeah.
Understand.
Okay.
And then also just I see in the slides that it's mentioned that our photovoltaic cells lose efficiency at higher temperatures. What is the reason for that?
That has to do with the material also itself. A solar cell is basically a semiconductor material, semiconductor device. And when you go deeply into the physics, there is a law that when the higher the temperature, it loses efficiency on the way these electrons and atoms move in the material itself. So this is basically something that goes with the material itself. You cannot change that. It just you have to cope with it. And there is always on every data sheet there is a number of this decrease of power according to temperature. This is something of 0.4% per degree centigrade. In very modern solar cells, this is 0.25% of power per degree centigrade. So every 10 degrees of centigrade, you lose about 3% of power. That is the idea.
Thank you.
Excellent. So, colleagues, while we wait for the last few questions, I think you got a feel for how we're asking all different types of questions. I think you also understand there are colleagues that have got different levels of understanding in this conversation. But during the week, you can also ask questions on the chat. You're welcome to ask questions during the week as you're reading your questionnaire or handout or any questions. So on the chat, we have Jos and we have one or two other experts that are on it, and we'll ask them to help answer the questions. But also people like Ryan and David who are also helping. So this is meant to be a learning ecosystem. If you know the answer, you can also help answer some of the questions. So colleagues, you can ask. You don't only have to ask questions in the class, you can ask it during the week as well as you're going through your material. So colleagues, I'm going to ask for a last round of questions. If you want, if you maybe put your hand out or you can ask in the chat. But just on the way forward is that tomorrow, or if tomorrow's a holiday, Miranda will share the recording with you the day after, so you have an opportunity to go back or share it with your colleagues. We will share the new set of information or the new topic on grid-connected systems by Thursday, Friday, so you have time to read it in advance over the weekend and come prepared for Monday. But, as such a tweet. For those of you that need data for Monday, please let Miranda know next week by 12 o'clock or 11 o'clock in advance so she can load it. Miranda, you have your hand up? Did you put your hand up?
No, Cash, just in error. Yeah, I was just saying, all good. I'll send the recording links, etc.
Okay, fantastic. So colleagues, we're going to quickly go back to the chat. We've got 9 minutes more on this lesson, and we're going to quickly see if there's a comment from Orape saying it is interesting, but I still think fossil fuels are the best energy sector. Nevertheless, I'm enjoying this course. Okay, that's just a comment.
Yeah, but you can. This is a little bit a political question, and I also can give a political answer. At the moment, solar energy is the cheapest source of energy in terms of levelized cost of electricity. So the total cost of ownership in solar systems is lower than when you make use of fossil fuel. Remember that in fossil fuel, you don't own the whole value chain. You always have to go for diesel somewhere, and the question is if you get it, and if there is someone who wants to transport it, or if there is a government who wants to put electricity into the grid system, and is it coming from nuclear, or is it coming from fossil, or from renewables? And renewables you connect to the grid as a utility kind of energy source. But renewables you can also do very locally on a house level, and that is the big difference that you have with fossil fuel. Of course, you can say, and you can put in every house also a diesel genset, but then you have this machine that you have to repair, and then when you have to put diesel in, and when you compare solar to diesel to genset at the moment, the diesel genset is much more expensive than solar.
Okay, so that is the political question.
Yeah,
and thanks for
but
asking.
it is also we can also do that. You can also have spend half an hour of politics, but I like to do that. But whatever.
Okay,
you are the boss
cool.
in the group.
Excellent, colleagues. If there are any other questions in the class about the handout, so you're still allowed to ask more questions. Maybe you can just put unshare, stop sharing for a minute, so we get a bigger picture, Jos, of the class. If you can stop sharing for a minute. So colleagues, what we're saying is it's not the end of the discussion. Today was just to get into class, to have an opportunity to ask in class the different types of questions. But you can still ask your questions as we go during the week as such. So there's one question: how many batteries can you connect to a 5 kVA inverter? Marinda, there's one more person to be added on the WhatsApp group. If you can please add them.
Got it.
Yes, the answer is how many batteries can you connect to a 5 kVA inverter? The answer is?
There's also not a straight answer.
Yeah.
Depending on the size of the battery. When you have a 5 kilowatt inverter, put a 10 kilowatt battery, but it is not a straight answer.
Okay. So there's different factors.
Situation.
Okay. Yeah. So colleagues, I think the message from today is not one size fits all, into it. And I think there's many, of the questions that were asked is, we are going to have a special session on batteries. That's going to be session number 3. And then we're going to have a special session on how to size solar sizing, lesson number 4, be able to calculate with you how you go about it. So I think it's step by step. It's one size does not fit all. Marinda, you've just added, if you can just add that number 079, whatever, as well as the second number now, 066, onto the chat. So colleagues, I don't know if there's any other questions. If you may want to put your hand up, there's nothing else in the chat except the last 2 requests to add you to the WhatsApp group. If there are no other questions, there's 5 minutes left on today's meeting. So we will share, Marinda will share the recording. Later this week, we will send you on grid-tied systems the 2 videos that you need to listen to, and the handouts. We will share it to you in advance, and then we'll meet again next week, Monday. So Jos, deep gratitude. Thank you for taking the time. I think you've got a feel for the class and the questions and the variety of questions as to it. And remember, we're all on different levels, colleagues, into it as well. And so we will start to ask questions, but I also want to encourage you to start asking questions in the different chats as well. Colleagues, thank you so much for your time. Jos, deep gratitude. Marinda, thanks for facilitating. Guys, we will see you next Monday at 2 o'clock. Okay, bye. Bye.
Bye-bye.
Bye.
Hey guys, bye bye. Thank you.
Bye.